Okay, again today we're going to talk about atomic structure, and we're working on this idea of where is it that the electrons can be found. And so we're going to be continuing on that quest and talking about the energy that is provided by the electrons. Just a review again of John Dalton's theories. Some of you didn't do very well on this on the test. Some of you did a really good job. Elements made of tiny particles are called atoms. That is still true today. We do know that they are smaller, that there are other things that are smaller than that. However, what the statement says is true. All atoms of given elements are identical. We know that this one is not true because of the existence of isotopes. And again, elements can combine to form compounds. We're going to be working on that later, but yes, that is the case. And then the law of constant composition, which basically says you cannot create or destroy matter. Again, another reminder, J.J. Thomson, he was the one who said atoms of the same element could be made to emit tiny negative particles. He searched those negative particles with his experiment, and that experiment involved the cathode ray tube and a magnet, and he was able to find out that the negatively charged particles were called electrons. He concluded that there has to be some positive charges for those electrons to be hanging around. Then we go into Rutherford again. Remember, he was the one of the gold foil experiment. A couple of you got confused. His results basically, remember, he was shooting at the gold foil piece, and all of the sudden what he expected not to happen happened when it came back at him. And that what he discovered then was that there was a dense center, and that dense center is known as a nucleus. He concluded that nucleus must contain positively charged particles because at this time furthering J.J. Thomson already knew that the negative particles were in there. So he was able to get those known as protons. He also concluded that the nucleus was the home to neutrons as well. So the question comes then, if the electrons are negative and the nucleus is positive, then what happens and what keeps the atom from collapsing upon itself? And so we're going to look into this and see what the electrons exactly are doing. We're going to start this with this idea of electromagnetic radiation. I want you to think about this for just a minute. If you hold your hand a few inches from a brightly glowing light bulb, what do you feel? How about what happens if you move close to the glowing embers of the wood in a fireplace or in a fire? What you're feeling is the energy being transmitted from one place to another by light. Radiant energy that exhibits wave-like behavior and travels through the space at the speed of light in a vacuum is the definition of electromagnetic radiation. We've studied this and we made our books, and we know that there are different kinds of electromagnetic radiation, all the way from radio up to gamma rays. The last thing that we need to talk about today are this idea of wave properties, and there are some more properties that we need to discuss, but we're going to start with just this basics here. Wavelength is the distance between two consecutive wave peaks, and we look at it here in this one and we notice that the wavelength is here in the green, and it goes from the top of here through one cycle back to the other, and that's what we call a wavelength. Okay, that does not have to happen exactly in that spot. It could actually begin, and I'll use red to show you this, it could begin down here where I'm putting the mark and come up through a cycle and back down, and that be the wavelength. Or again, it could even start right here in the middle, come through this part, half, and another half here, and that be considered a wavelength. So what you're looking for in a wavelength is that it goes through a complete cycle. The next term is frequency, and what we're looking for in frequency is how many wave peaks pass a certain point in a given time period. This time period depends on what you're looking at, but what you're trying to do is see how many of the peaks come through in a given time. So you have to define that time, and then as however many times the crest passes. And so that leads us to a next question, is what is a crest? And so we're going to draw another one down here just so that we can see it a little bit better. The crest is the top part up here on the top of the wave, we call that the crest, and the very bottom part down here we call a trough. And so we need to know both of those terms. Amplitude then is how far from the middle does a wave go. And we notice in our drawing over here, we have this dotted line here in the middle. And what they're talking about is how far up or down from that dotted line, from the center, does the wave go. And when we're talking about that. So again, if we were to draw one here and put our line in, we're talking about how far up or down that wave goes from there, and that is what we know as the amplitude. Okay, the last thing that I'm going to ask you to do is to be able to use this electromagnetic spectrum, not just to know what it is, but to be able to use it. I'm going to be asking you some questions in here, and the questions are going to pertain to the wavelength, which we can find right here, and then the different frequencies, which we can find right here, and we'll be able to answer these questions with that. For instance, like the first one, in each of the following pairs, so we're going to talk about this pair here, I want to know which one has a longer wavelength. And the question I'm going to ask first is red light or blue light. And so what you would do is you need to look right in here in that visible spectrum. Remember that not all that light can be seen. And so we have to look in what we can actually see. So when we go here, we have the red on this end over here, and we have the blue on this end. And so if we wanted to know which had a longer wavelength, where is that longer? And it would be longer closer to this end, so the answer to that would be red. And so we're going to practice a few of those. Another type of question would be which one has a greater frequency. And I'm talking about down here now, yellow light or green light. So again, we need to look in that same area here in the middle, and I'll erase that so you can see it, but we need to look in that same area here in the middle, and we again need to look for the difference between yellow light, which will be right in here, and green light, which would then be also right beside it, but which would have the greater frequency. And as we notice, the frequencies get larger as we go up, so the answer to that question would be the green light. And then I want you to practice those and finish up the rest of the questions.